Okay, so let's look at this problem from operating system. Consider three CPU intensive processes which require 10, 20 and 30 time units, okay, and they arrive at times 0, 2 and 6 respectively. How many context switches are needed if the operating system implements a shortest remaining time first scheduling algorithm? Okay, do not count the context switches at time 0 and at the end. Okay, so out here we have three CPU processes, okay, and they require these 10, 20 and 30 time units, and they arrive at these different 0, 2 and 6 times. And then we have to tell how many context switches are needed. So context switches, when one process is running and then this process is replaced by this other process, okay, so that's context switch. And so how many of those context switches will be needed if shortest remaining time first scheduling algorithm is implemented? Okay, so in this case the algorithm that has shortest remaining time is run first. Okay, that's this algorithm. So let's do this thing. Let's first have a timeline. Okay, so suppose this is the timeline. Okay, and then what we'll do is we will have this 0 like this, okay, 1 and so on. So there is this 2 and 3, 4 like this you go, and then you have 6 like this, okay. And then what you know is that this process, so there is a process that arrives at time 0, okay, and there is this another process that arrives at time 2, and there is this another process that arrives at time 6, and then you have to run them in the order of shortest remaining time. So the first process that arrives at this time 0 is, it needs 10 units, okay, so it will run, okay, at this time another will come with 20. So this first process, okay, so I'll call these processes P0, P1 and P2, okay, this P0, P1 and P2 with their different times like this, 10, 20 and 30 times. So this P0 will run first and it will keep on running. At 2 the another process will come which is which needs 20 time units. So P0 is still 8, we still have 8 time units, so it's shorter. So P0 will keep on going, okay, and then when this process comes it needs 30 which is still greater. So P0 will keep on going up till this point, that is 10, okay, that 10 time units. And then what is the next one with shortest remaining time will be P1 with 20 time units, okay, and then from 10 for another 20 time units it will run, that is at 30. What we will see that another process, the last one with 30 time units will start running at this point, which is point uh, P2, and this will run up till 60, okay. So that's what we have so far, okay. So this is what will happen in case of shortest remaining time first. And so the context switches, you have to count the context switches, but we don't count the context switches at time 0 and at the end. So when process P0 started there must have been a context switch out here, but we don't count this time. And when P2 ended out here there must be a context switch out here, we don't count this. So there is one context switch out here and there is another context switch out here, and we count only these two, and that means that it is two context switches.